Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll solve this problem using the concepts of horizontal asymptote. So as per the problem, determine the equation of horizontal asymptote, then state whether the curve approaches the asymptote from above or below. So let's start with the function on the left side. G at t equals 3t squared plus 4 over t squared minus 1. So as we know that this is a rational function. So in order to find the equation of the horizontal asymptote, we'll have to evaluate the limit for this function at t approaches infinity. Now before we do that, we have to modify this given rational function. So the first step is to identify the degree of the denominator of this function. So the degree of the denominator is equal to 2 because that's the highest power on the variable in the denominator. So that means we have to divide each term in this rational function by t to the power of degree of the denominator, that is t squared. So we should divide each term in this function by t squared. So we get g at t equals, so in the numerator we get 3t squared over t squared plus 4 over t squared, then divided by, we get t squared over t squared, and then minus 1 over t squared. Now we can simplify this expression. So g at t equals, now in the numerator, in the first fraction we can cancel out the t squares, so we just get 3 and then plus 4 over t squared. And in the denominator, in the first fraction we can cancel out the t squares, so we just get 1 minus 1 over t squared. Now we can evaluate the limit as t approaches infinity, so we write limit t approaches infinity, so 3 plus 4 over t squared over 1 minus 1 over t squared. Now we can apply the limit. So if we do that, we get 3 plus 4 over infinity squared over 1 minus 1 over infinity squared. Now we can simplify this expression. So 4 over infinity square is just 4 over infinity. So we know that 1 over infinity is equal to 0. So the numerator becomes 3 plus 4 times 0. Because 4 over infinity can be written as 4 times 1 over infinity. And then over 1 minus 0. So now in the numerator, so 4 times 0 is 0. So 3 plus 0 will just be 3 over 1 minus 0 is just 1, which is equal to just 3. The equation of the horizontal asymptote can be written as y equals 3. So this should be the final answer for the first part. Now we can evaluate the limits on the left side and the right side using a big negative number and a big positive number to find whether the curve approaches the asymptote from above or below. So we'll apply the limit. So let's start with the left side. So limit t approaches, so we can use a big negative number like negative 100, and then the given function is 3t squared plus 4 over t squared minus 1. Now we can apply the limit. So we get 3 times negative 100 squared plus 4 over negative 100 square minus 1. So now we can evaluate the numerator. So in the numerator, negative 100 square is 10,000. So 3 times 10,000 plus 4 is equal to 30,004. Over in the denominator, negative 100 square is 10,000 and 10,000 minus 1 is 9999. Now if we evaluate this fraction, we get a value greater than 3. So that means on the left side, the curve approaches the asymptote from above. So we can write, so curve approaches asymptote from above on the left side. Now we can do the analysis for the right side. So for that we'll apply the limit. So limit t approaches positive 100 and the rational function 3t squared plus 4 over t squared minus 1. So now we can apply the limit. So we'll sub in t as positive 100 plus 4 over 100 squared minus 1. So in the numerator, we get 30,004 and in the denominator, we get 9,999, which gives us a value greater than 3. So that means the curve approaches the asymptote from above on the right side as well. So we can conclude the curve approaches asymptote from above on the right side. So now we are done with the analysis for the first function. Now we can analyze the second function. So first we'll have to find the equation of the horizontal asymptote. So for that, we will analyze the degree of the denominator, and in this case the degree of the denominator is equal to 1. That means we have to divide each term in this rational function by x raised to the power of degree of the denominator, which is x exponent 1, which is equal to just x. So our first step is so y equals the numerator, we divide each term by x, and we'll do the same in the denominator. So x over x minus 4 over x. We can simplify this expression. So we'll start with the numerator. So x squared over x can be reduced to just x. So we get 3x minus x over x with 8. They cancel each other out. So just 8 and then minus 7 over x. And in the denominator, in the first fraction, the x's cancel each other out. So 1 and then minus 4 over x. Now we can apply the limit x approaches infinity. So we get 3x minus 8 minus 7 over x over 1 minus 4 over x. So now we can apply the limit. So we get 3 times infinity minus 8 minus 7 over infinity over 1 minus 4 over infinity. Now we can simplify this expression. So 3 times infinity is just infinity minus 8, and then 7 over infinity can just be written as 7 times 0, because 1 over infinity is equal to 0 over 1 minus 4 times 0. Now 7 times 0 is 0, so we are left with just infinity minus 8 in the numerator over 1 minus 0. Now infinity minus 8 is just infinity over 1, which is equal to infinity. That means this function has no horizontal asymptote because the result of this limit is infinity. So our conclusion here will be no horizontal asymptote. So that means we cannot find whether the curve approaches the asymptote from above or below because this function has no horizontal asymptote. So these are the steps you have to keep in mind to solve a problem like this one. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.